In class, we talked about how to find the velocity function and acceleration function, basically the first derivative and the second derivative. So let's look at this example. From the point at which an object is dropped, the distance it falls in t seconds, assuming negligible air resistance, is approximated by this distance function. I'm going to highlight this in gray. So whenever you want to find the distance this stone traveled, by the way, we're throwing a stone. If a stone is dropped from a cliff, find each of the following. The first part is asking you how far the stone has traveled 5 seconds after dropped. So if they ask you for how far, they're asking for the distance. So plug in the 5 into the distance function. So S of 5 equals 4.9 times 5 squared. So what's that going to be? Let me open up my scientific calculator. That comes out to be 122.5 meters. So we didn't have to take the derivative when they are asking for the distance function because we already have the distance function. But I see for part B, they're asking for how fast. Well, how fast is their speed, right? It's the velocity. So to find the velocity function, we have to take the derivative of the distance function, okay? So what is the derivative of this? Okay, you will have to do 44.9 times 2, right? That will give you 9.8. And t's new exponent is down to 1 now. So we can just say 9.8t. So the velocity after 5 seconds being dropped is going to be 9.8 times 5, and that comes out to be, let's see, 49, and the unit for velocity will be meters per second here. Okay, now let's look at the last one. They want us to find the acceleration. Well, they want you to find how fast the velocity is changing. So if you want to find the acceleration function, find the derivative of the velocity function, which, by the way, is the second derivative of the original distance function, right? So take the derivative of this 9.8t. That is just 9.8. So acceleration is constant in this case. So for falling for 5 seconds, well, it's going to be 9.8 no matter what seconds. The unit for acceleration will be 9.8 meter per second squared. So that's how you can do this distance, velocity, or acceleration problem.